Welcome to the session. So, in this session, I am explaining about quicksort. It's one of the important sorting technique. So, the name itself shows that quick. The name itself says that quick means it's a very fastest sorting technique. In the unit starting onwards, I told that. So comparatively means two different metrics we are designed, time complexity and space complexity, and a problem having n number of solutions means n number of solutions are feasible solutions, in that one of the optimal solution. So in the sorting category also we are knowing about insertion sort, selection sort, bubble sort, quick sort, mid sort, radix sort. So these are the different kinds of sorting techniques. In all the sorting techniques, which one is an optimal one is quick sort. So this is the most efficient sorting algorithm, and it follows divide and conquer approach. So in the quicksort algorithm, mainly two parts. One is partition, means partition the original array. So divide means also same, like a binary search. When we are calculating the mid element, based on mid element, we are dividing the array into two equal halves. But here we are choosing some pivot element. Based on the pivot element, we are dividing the array into two halves. That is not an equal. Maybe it is an equal, maybe not is an equal. So, and the next thing is, after that, we are forming a group of elements. Arbitrarily, and based on the group, again we are applying quicksort technique. So, pictorially we can show it. Say, initially we are taking some pivot element. So the partition function divides this array into pivot comes to the certain position, and less than pivot means comparatively pivot, lesser elements are comes to one side and greater elements are comes to one side. So here we are called as, this is some arbitrary groups, and here we are called as some arbitrary groups. And again we are applying sorting on left side of an array and right side of an array. This process recursively applied. This process is recursively applied until we get a sorted array. That is the quicksort technique. So in the quicksort technique, we are mainly applying three kinds of operations. The first one is partition function. We know it. So in the partition function, here we are checking that A of up greater than or equal to pivot or not. A of up means here two pointers are there. One pointer is up, another pointer is down. Sometimes we are called it as, this is least, this is called high. So the process starts from initially either first element or a last element, or randomly we can choose one element is a pivot element. By comparatively pivot element, up point element should be greater, otherwise the loop breaks at the such situation. Similarly, the down pointed element should be lesser element comparatively pivot. In other case, definitely the loop will breaks. So when we are getting a down element and up element, by comparatively positions of down element and up element, we are swapping each other. So once we are going to an example, we can know what is the technique clearly. Say, this is a very simple example. Just see, here also the array index starts from 1 to 13. These are the elements 38, 8, 16, 6, 79. These are the elements. So initially we are assuming that the first element as a pivot element. First element is a pivot element. The next we are starting up, and there we are starting down. Up, down. So comparatively 38, 8 is less. 8 is less means yes, true. Moving to the next direction. 38, compared to 38, 16 is less. Compared to 38, 6 less. Compared to 38, 79 not less. So here breaks the loop. Breaks the loop means in this case the loop will breaks. The next 38 comparison, 38 45 greater, right? 38 70 greater, right? 38 4 not a greater means here breaks the loop. So what is the values? Down value is 11, up value is 5. 5 less than 11 means swap these two elements. So 4 comes to this side, 79 comes to this side, means swapping. Next, iteratively doing the same process. When we are saying that 38 comparatively 4 is not greater, means indirectly it means less. So no need to compare again here. Automatically up pointer move one time. So the next 38 is compared with 57. Greater. Breaks the loop. The next here 38 comparison 58. Yes, this is greater. Condition true. Moves to the next time. 38 comparison 2. No, it's not a greater one. Means condition fail. So here condition fail. So what is the down value? 9. What is the up value? 6. 6 less than 8 means these two elements are swapping each other. Means 2 comes to here, 57 comes to here. The next 38 is compared with 24 less. 38 is compared with 56 not less. So up breaks in this time. Similarly 38 is compared with 56 greater. It is true. 38 is compared with 24 not a greater one. Break this time. So at this time up value is 8. Down value is 7. 8 not less than 7. 8 greater than 7. When the up pointer, down pointer cross each other, automatically breaks the particular pass, and we are swapping pivot element and down element. So pivot comes to the 38 position and down points to 24. 24 comes to this position. This is the partition function operation. So 38 comes to the fixed position. 38 comes to the fixed position. The left hand side elements all are less than 38. The right hand side elements all are greater than 38. So this is the way we are dividing array into two halves. The next, recursively we are performing partition function, means quicksort for this array, and recursively we are performed partition function and quicksort for this array also. This is the quicksort technique. So better understanding, we'll go for a very simple example. Say in the past one, so 5, 1, 4, 2, 3. So I am assuming that this is a pivot element. So we want to assume the index. So 0, 1, 2, 3, 4. So here up points to 1 up value is 1 and the down value is 4. Comparing 5 comparatively 1 less, condition is true. Comparatively 5 4 less, condition is true. Comparatively 5 2 less, condition is true. Comparatively 5 3 less, condition is true. Means here there is no elements. Means that there is no elements. Means this is the right position. Right position means when we are starting down case. Down case. So 5 is compared with 3. Not a greater. Not a greater. So here loop failed. So in the loop failed case, up value definitely 5. Down value is 4. So up value, down value both are crossed each other. What happens? What is the element point out by down and pivot? Both are swapping each other. So 3, 1, 4, 2. This is a 1 array and 5. See here very important one is right hand side is no elements. That's why I told not equal partition. Based on the pivot position, it divides the elements. So comparatively 5, all the lesser elements are coming to the one side. Greater elements are no, means nil. So again we are applying quicksort on this set of array. Say 3. 3 is a pivot element. Up points to. So 0, 1, 2, 3. So up points to 1. So comparatively 3. 1 is less. Condition is true. Comparatively 3. 4 is not less. Break. So up value is 2. Up value is 2. Then we are starting down time. So comparatively 3, 2. Not less. Not greater. Here less. Means condition failed. So down points to 3. 2 less than 3. 2 less than 3. What happens is these two elements are swapping each other. Means that 2, 4. 2, 4. The next recursively 3 is compared with 4. What happens? Condition is failed. So up failed at what is the position? 3. Up failed at position 3. So the next down compared here. So 3 is compared with 2. Not a greater, less, failed. So at this time up value, down value. So up value is 3, down value is 2. 3 less than 2. No, condition fail. Means that 3 greater than 2. So what is the down value and what is the pivot? These two are swap each other. So what happens? What happens? So 4, sorry not 4. So 2 comes to the pivot position. So 2, 1. The next 3. So this is one side, 4. 5 is already fixed. 5 is already fixed. So the next time, again quicksort applied for this elements. Again quicksort is applied for this elements. So 2, 1. So 2 is a pivot element. Up points to this one, down points to this one. So 2 is compared with 1, less. Condition is true. So it goes to the next position. There is no element here. Break. Next, 2 is compared with down. Fail. Close. So what happens? Up value here, down value is here. Means both are cross each other. So what happens? What happens? Pivot and down elements are swap each other. Means 1, 2. So 3, 4. 4 is a single element. So I already told in the insertion sort case also, single element is treated as itself sorted. Single element itself is sorted. So This is the quicksort technique. It's a very, very important technique. Once we have practiced, it's very easy. You can easily go through that. But this is a vast kind of thing. Vast kind of thing means we are getting only one side of an array, other side of array we are not getting. Okay, the next, what is the algorithm for quicksort? So here two functions are there. One function is partition function. So algorithm partition. Algorithm partition. So here we need three parameters. Three parameters. Generally H refers to N. H refers to N. L refers to up. H refers to down. According to the algorithm. Means based on previous manual examples, we made it as L value as up, H value as down. So H value refers to size of an array. But here we are taking starting index. Starting index. So in the partition function means initially the first element is taken as pivot element. So that pivot is equal to the first element. So A of L is a pivot element. After that, we need to copy up index in one variable, down index is a one variable. So X is equal to say L. X is equal to say L. And Y is equal to say H. Y is equal to say H. And sometimes they are taken as L plus 1. Why? Because L value is in pivot position. L value is in pivot position. So what we have to do? First, I already told the condition while X less than Y. While X less than Y. Up to X less than Y, we are doing the operations. So what to do? So while here we are getting the conditions. So A of pivot. What happens? A of pivot point out by X. Means that, right? So see, here pivot is an element. Here pivot is an element. So comparatively, pivot is an element. So pivot. Comparatively pivot, what to do? So pivot, and we need to compare A of X. Pivot and A of X. When we are moving to the next position, condition is true. So comparatively pivot, A of X should be less. Means less than or equal to. Do. What happens? X is equal to X plus 1. Similarly, while pivot greater than A of Y, what to do? Simply Y is equal to Y minus 1. So what to do in both the cases? If X less than Y, X is the index, Y is also index, we are comparing both the indexes. So X less than Y, what happens? Simply swap A of X comma A of Y. Simply swap A of X comma A of Y. In other case means suppose X less than Y, condition is failed, X greater than Y, what to do? So swap A of down pointer. Down means nothing but h. Means that here a of y comma pivot is swapping each other. Or here you can mention as a of l. These two are swapping each other. So this is the partition function. This is the partition function. So one loop moving to left to right, one loop moving from right to left. We need to check x value, y value, where it breaks. So x less than y, swap a of x, a of y. Suppose condition fail, swap a of y comma pivot element. This is outside the while loop. So this is the partition function. And next we go for recursive function. So in the recursive function category, so algorithm, quicksort, here A, L, H. A, L, H. It's a very simple thing. So if L less than H, then if L less than H, then what happens? What happens is, say for suppose partition position say P is equal to, so part means previously we have defined a function partition, so part A comma L comma H, A comma L comma H. So recursively we are applying quicksort after this. So quicksort of A comma L comma P minus 1. P comes to the pivot position. Pivot position comes to the fixed position. So that's why P minus 1. The next quicksort of A comma P plus 1 comma H. This is divide and conquer. So here we are divided and here we are recursively applying the quicksort for the left side of the elements and right side of the elements. In the next slide we will continue. So T of n is equal to 2 into T of n by 2 plus Cn. What is this equation? So n means we are taking array n number of elements. So when we are applying partition function, the array we are expecting that the pivot comes to exact mid position and the array is divided into two equal halves. So T of n by 2 and T of n by 2 means here n elements. So n by 2 is one side and n by 2 is another side. N by 2 is one side, n by 2 is other side. So the time complexity of n by 2 again we are calculating. So that's why 2 into T of n by 2, and this is the partition function time complexity. This is the partition function time complexity. So here whenever we want to solve this recurrence relation, we need to calculate T of n by 2 value. So T of n by 2 is equal to 2 into T of n by 4 means n by 2 by 2 means n by 4. See n by 2. N value is n by 2. We are substituting this equation into here. So 1, 2, 2 is substituting into 1. What happens? So T of n is equal to 2 into T of 2 into T of n by 4 plus Cn by 2 plus Cn. When we have simplified this equation, 2 into T of n by 4 plus Cn, this two is cancelled. So Cn plus Cn means here we are getting 2 into T of n by 4 plus 2Cn. 2Cn. Again you are calculating T of n by 4 and substitute into here. What you get? Suppose we are substituting recursively. T of n is equal to 2 into T of n by 8 plus 3Cn. So here this is written as 2 power 3 T of n by 2 power 3 plus 3Cn. See, we are getting two common terms. So definitely one certain case the elements are coming to 1, means array size is 1. At the time only the recursive loop is breaks. We know that an array consists of one element, definitely the array itself sorted. So means this one is 1, means n by 2 power 3 means 1. So this is generalized case. So n by 2 power k is equal to 1. Means that n is equal to 2 power k. N is equal to 2 power k. Means that k is equal to log n base 2. K is equal to log n base 2. So here this is substituting here. What happens? So 2 power k value is nothing but n, means n. After that t of 1 plus 3Cn. N value means log n base 2. Means log n base 2. Before this, we need to write some k term first for better understanding. So 2 power k t of this one is as n by 2 power k plus this is called kcn. kcn. So here 2 power k value is n, means we are getting n, t of 1 value is 1 plus k value is log n base 2. So Cn log n base 2. So by comparatively n and n log n base 2, this is the mode value. This is the mode value. Means simply we can say that the time complexity of quicksort is big O of n log n base 2. N log n base 2. So this is the time complexity of quicksort. Best case big O of n log n base 2. Average case big O of n log n base 2. But in the worst case, the time complexity of quicksort is big O of n square. Worst case means what? Worst case means what? In the previous example I told, that is when we are applying quicksort, here we are getting 5 comes to the one position. The one array means left side array is n minus 1 elements and right side array no element. That is the case of worst case. Worst case. We are choosing the pivot, that kind of case, definitely it is the worst case. So I already told in the previous example, the worst case thing is, the worst case of input is exact reverse to the required one. The required one is ascending order, this is a descending order. Say for suppose you want to apply quicksort for this case, each and every pass we are getting either left side array or right side array, not both. If you want to check it out, check it. So that's why the quicksort exhibit worst case behavior in the worst case. Means when the elements are in the descending order. Means exactly reverse order. So that's why worst case the time complexity is big O of n square and best case and average case is big O of n log n base 2. So comparatively n square, n log n is the less. That's why quicksort is a efficient, effective sorting technique. So, summary. Here we have discussed about quicksort. In the quicksort, we have explained about two different kinds of functions. One is partition function and another one is recursive function. And we have explained the procedure for both, and then we are computing the complexity of quicksort. We are computing the complexity for quicksort. So this is a very, very important concept, no doubt. Quicksort is a damn sure question in the external examination. Thank you.